How's it going, everyone? Welcome. Javier Gonzalez here, and today let's going to look at explore is the chapter 2. So, this is part of the series or the book written by Kyle Simpson, where he described is based on his experience the reason why we need to learn JavaScript, and ultimately if you truly want to understand this, you will save a lot of problems and a lot of issue as it comes to. So you can have now time to dedicate to other stuff, to explore is now what you can do with the language. And I think that's quite beautiful. And also ultimately, uh, the reason why also you're getting paid for, all right? It's like not that you are only be able to provide some maintenance, okay, but also what you can build with this. So this is why I actually take note of this book, and to understand how do we get here specifically in this chapter 2, the survey JavaScript, is by understand the chapter 1, right, about the what is JavaScript. So in this model we look at what is JavaScript, where did the name come from, who made this, where were the assumptions that the language made for those who are for those who wants to get involved into this language, as well as what is the target audience, who actually owns the trademark, and the technical specifications, and who oversees that, and what these people actually guarantee, which is providing now a way of flesh to review and add new features to the language, right? So this is known as the TC39. They actually have a series of stage to pass through one champion or proposal to actually be implementation for the current implementation, and then how now this is something that all JavaScript implementation must follow, and if they don't, they can choose to not to. All right, and there's some use case out there in JavaScript where or some events that happen. So, for example, the Smooshgate, where the TC39 actually have to come back to the drawing table and now update or refine the proposal. This is something that is quite rare, but it happened. But the thing is that it shows that despite that the people in that commit, which is made of for several folks that works in several of this web industry related, whether it's the browser makers or the device makers, right? So Samsung, right? You name it. They don't know the reality of the web, and this is crucial because from this point, which is something that happened a lot of as a JavaScript developers, that we don't understand, or we have now a version of the reality of how the language works in our mind. And when that happens, something that this is the Getify law, the Kyle Simpson law, sort of speaking, is that when that happened, this is when a bug it was introduced. So the idea of doing this recap, especially with the language, with the JavaScript, is just to understand what the language is, why it exists, as well as the surroundings, the environment that are on top of that. And speaking of environment, is that there is a huge collection of environment that you can run JavaScript, whether it's a browser, the server, light bulbs, robots, you name it. And so, because all of those environments, the reality would matter is the web, right? And because not all things are the web, or not all things are JavaScript. For example, in the developer tools, that this is just a friendly environment where you can execute is JavaScript. And for example, I mentioned this is because in the language, for example, like this, right? So the language in itself, especially here in this console, doesn't behave the way how JavaScript works. How true a JavaScript engine will process your file. And speaking of, so for example, a good example is the use strict, all right? So the use strict here is only per season, all right? And not only that, because this strictness actually it enforce, or this strictness what is convey is to let JavaScript developers follow the best practice of how they can use the JavaScript to optimize and running code in the most fast way possible. So this is sort of the semantics or chains that actually modify the behavior of JavaScript. And the more you're aligned to this, the more you can actually understand, for example, is directive like use client or use server in React, and you can see the evolution of the language. So for example, in a strict mode, the value of this instead of a function is now a is now a undefined, for example. So for example, here you say something like this, and then you try to call this function with the value of this, right? So the value of this now is now undefined. So unlike that, like this, come on. So unlike without the use strict, all right, which is, remember, it's interesting because this is per season, all right. Now the value of this is window, but all of this is strictness, that is this set of rules that you must follow. Another rule is that with functions parameter, is that each one of those parameters, they must not have the same name for that. Otherwise, it will break that, or it will create now a problem. Otherwise, it will break. Otherwise, it will throw an error. So you have now the use string with the function, and just to illustrate that, you can here define some variables here. Let's say variable 1, and then you assign that to the variable 1, right? And once you run this, it says that, hey, you shouldn't define this as it is, right? If you want to do that, you must provide is the variable as it is, the identifier from that. You can also for example, in non-strict mode, you can say something like this, right? So when you define here, it will actually cast that. So the idea of this is strictness, and among other things, because, for example, hosting and so on and so forth. So, but the idea of this strictness is to let the JavaScript developers convey to what is to convey to notify the JavaScript engine to have a good chance to optimize and have a code running as fast as possible. So because the concern of the language is that it is not fast enough, because the way how the language works, and that is, this is a compiled language. In other words, because a lot of people might think that this is a interpreted language, but the reality is that it all boils down, the heart of this is a parse language. How do I know that? Because when you're trying to do some when you do some syntax error, the language in itself actually is throwing you some errors. A good example of that is when you put different codes in variables and so on and so forth. This is telling you how now JavaScript actually works, all right? And because JavaScript, unlike, for example, compiled languages, or because uh, compiled language, uh, unlike interpreted language, right? When you have now in the compile, you have all of this set of instructions, and when you compile that, it's going to transform into an abstract syntax tree by and usually generate is a binary portable distribution that can be executed on any of that distribution. Okay, so because this is something that is optimal for the distro that can run that particular code. In the case of interpreted language, the issue boils down is to the error here, is how now the errors is being handled. This is the heart of the discussions of the compiler versus interpreted language. Because, for example, if you have an interpreted language that at some point, let's say you have now five line of code, and then at the line 5, that particular line actually throws some sort of errors, reference error, some syntax error, you name it. So the language in itself, the interpreter, have to go all the way down into that. So this is something that is going to waste your time, unlike a compiled versions where it can determine that at build time by analyzing all of the entire code. But the thing here is that this debate of interpreted and compiled language, all right, it is because JavaScript in its nature is needs to process several files at run times, all right, that cannot be is compiled entirely, all right. So there are, this is, for example, is sometimes you might want to now, this is true, for example, for a lot of these e-commerce applications. When they want to navigate to a particular section, you have to pull the data or the JavaScript files for that person, and so on and so forth. So the engine has to now is verify that the code actually works by passing through this parsing and then execute it. And this process in the compiler lands, all right? So it is now tokenized that to identify is what are the operators, the values, the identifiers, the keywords, and so on and so forth. All of this stuff that are defined by the language, all right? And then putting all of these buckets to then create now this internal representation, this internal map of this, which is the abstract syntax tree. And with this abstract syntax tree, now it's going to generate is the binary code, right, by the language. So unlike now JavaScript, what's happening here is that when your JavaScript file leaves the ID, it's gonna pass through a transpiler, which is a way of how now this JavaScript code actually is available for all of these browsers out there, their runtimes out there, okay? That when that happens, it's also going to be bundled up or pass through a series of build steps as a way to bundle up or to whatever technique that they're using to actually improve the performance or the speed of running, yada, 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 right? And that is then ready to be delivered. So when the file arrive, your file, or when that file arrive your JavaScript engine, it takes that, it parses that to detect for any syntax error, all right? Uh, and then internally it's going to convert that into an abstract syntax tree that inside of the JavaScript engine is going to be passed through a compiler or a profiler, all right, depending on the implementation of the JavaScript engine, right? For example, in the case of V8, you have now the profiler, all right? That's what it's doing, is to look for way of how can identify code to pass down to the compiler for further optimizations. So this refinement, all right, that is when it parses and converted into a syntax tree, and then it's converted into some intermediate representation of the code that given the profiler, all right, is going to now doing some further optimizations until you have the code ready to be executed. This is what happened on the JavaScript engine, right? Some variation of that. You have JavaScript Core, for example, for React Native, or you have now the Node using V8, right? Or you have now Chakra or Spider Monkey on the browser. But the thing here is that once we're able to understand how JavaScript works, and also the patterns that it allows us to write solutions to problems, or to dive deep into the problem, into the solution, all right, is that at the end of the day, um, this is what the language actually did, all right? In this particular paradigm, whether it's object programming or functional programming or procedure, which is our specific way of how you have a problem and how do you approach to a problem, all right? So for example, anytime that you need some computations, or when computation is required, you go into this functional programming as a way to save a lot of the errors, or to have this particular approach to solve problems. Anytime you need some calculations and some computation, you go there, or you can, is anytime that your problem demands some sort of communications and coordinations, object programming seems to be the good way. And the thing is that they don't exclusively, they don't are mutually exclusive. In fact, they are tightly coupling sometimes, all right? But the thing here is that despite of knowing how the language works, and that if in essence, if not in practice, JavaScript is an interpreted language, that also opened up a discussion about the WebAssembly. The TLDR with WebAssembly is that a.gsm, which was an intent, which was the way of, it was the act of porting the code from JavaScript, the code from Unreal Engine game into the browser by extending is the language, which was a subset of JavaScript engines, which passing some hints to the language, all right? Or in this case, which pass some hints to the JavaScript implementations. The thing here is, this was an attempt to see that JavaScript is something that can be fast to actually run that particular game. And then there was now, several years later, the WebAssembly would say, hey, we want to take the inspiration of ASM. This is, we are the spiritual successor of the ASM, as a way to now not only is be a subset or a language in which you can now port code from one environment to another, from one language to another, because they want us to now act as an environment that can, through a language which resembles like an assembly, right? It can now move that to the or it can now is act as a universal compiler, act as a universal compiler target. So you tell, for example, Ross, hey, I want to convert that, given that particular compiler, I want to convert that into this WebAssembly, all right? Or I want to convert now is the Rust or Java or C++ or JavaScript into this WASP, so I can execute that into a particularly WASP WASP environment. All right, and the idea of this is that this WASP is not a replacement of JavaScript. This WASP, what it is to uh, act as this universal target compiler. All right, so where the K now actually is run code in those environments. This is some quite pioneer stuff that the people that are facing these kind of problems actually, for example, Netflix or Google, when now when scaling actually is a problem. Uh, so this this particular scaling problems is something that, yeah, this particular scaling problem is something that we must need to understand. I think that go beyond the scope of this course. Uh, but the thing of JavaScript is that, right? So this huge overview of the language, and then now actually serving is JavaScript as a way to understand our assumptions here is that each file in JavaScript is its own program. So this can be quite counterintuitive, and you can think of this because the way how now the language actually process those files, all right, and it is boiled down to how these particular files, which is bundled up by the bundler or any model bundler, right, and then once the file is delivered, arrive the JavaScript engine in how it's processed, all right, but the reality is that each one of those files are now its own programs. So this is not the case unless that particular collection of programs, that those standalone programs shares a global or share the state via the global scope, so they becomes now is at runtime a single one file, right? So this is something that is quite ephemeral, quite somewhat intangible, because every time that you receive, for example, a particular file, let's say you are loading several of your files, and one of them is Google Analytics, some tracking GS for error detection, and so on and so forth. So if one of them if one of those programs actually fail, whether it's at parsing or at execution, all right, at best your application will operate partially, which is an example that I have in Carrefour right now, which was like that. It's like, hey, at this is gonna operate partially. So, but in any case, the thing here is this is something, even though, for example, now in the EX6, things like import or script type models, all of these are treated like single model or single file, that these collections of files, when they call at runtime, they will act as a single program. So this allows runtime interoperations between them. So regardless with code organization pattern, a loading mechanism is used for a files. Okay, regardless how the code structure. Okay, regardless of which code organization, uh, and this co-organization is whatever it is, right? Regardless of co-organization, whether it's a state-based or functional procedure, object programming. So regardless of the co-organization states and the loading mechanism is used for a file, stand or model, you should still think of each file as its own mini program, which may, exactly, which may then cooperate with other mini programs to perform the function of your overall applications. So, good, good. So the other is the values. So values, the most fundamental unit of information in a program is a value. Values are data, and they are how the programs maintain states. So, so so the most important information of the most important unit of information, and there are several units. So for example, the time, the money, the weight, so on so on so forth. So the most important unit of program is value. All right. So the most fundamental, yeah, the most fundamental unit of information is program. The most fundamental unit of information of a program is the value. So values uh, is the way how they maintain a state. Okay, and this is important to understand that values are data, and they are how the program maintains state. So the way how the data is maintained, all right? So the way how the data is maintained is through, and I think this is quite interesting. This kind of question is quite relevant. It's quite important as a way to not only understand why you're actually working and building and so on and so forth, but to have a more practical approach to this. So values are data, which is the most important unit of information, which is the data, all right, which is these values, that they are how the data, or they are how programs maintain a state. Okay, and again, this is something that is might be quite silly to understand, and in this three sentence actually encapsulate all of the things that we need to know, especially as we build programs, as we build set of instructions, and how those instructions actually are kept, or how those state are now kept. And why this is important to understand is the different way of how you can keep the state of a program, all right, through values, such as, which is something that I know that go beyond the scope of this, but such as the undefined, null, string, boolean, number, symbol, object, and I think I missed one. So you have is undefined null, string, number, symbol, big int, and objects, right? So you have this 7 one. So yeah. So string boolean. Exactly. So you have string number, boolean, undefined null, big int, and object. Right. A single moment. String number, boolean, symbol, boolean symbol, big int. You have undefined and null, and then you have objects. It's 8 primitive. It's 7 primitive. In fact, 7 primitive. And 7 primitive is that values that you cannot be broke down. It's the atomic values, right? So values come in to form primitive and objects. So the way of how you can now tell your program to store, to keep the state of the program is through values. And this primitive and this object here is the two-way of how can we now keep the state of our application. All right? That's interesting. That's interesting. How can we maintain the state of our applications? Through a primitive, as I mentioned before, and through an object. So values, I think, let me actually take note of this. Is this one? So yeah, this might be quite duh, but it's important. At least to me. At least to me. All right. Okay. Oops. So values. Exactly. So values are. So the most important unit of information, which is something that Claude actually described. I think that's quite interesting. So the most important unit of information is the value, right? So values are data, and exactly values are data, and this is the way. This is how programs keep the state. This is how the programs keep their state. All right, or maintain state. This is how the programs maintain state. All right. So in JavaScript, we have primitive and objects. All right. Primitive and objects. And values are embedded in programs using literals. So for example, like this. In these programs, the value, my name is Kyle, is a primitive string literal. Strings are ordered collections of characters, usually used to represent the words or sentence. So here we're starting to describing is the different values that we can have, right? Yeah, you got it. So, exactly. So primitive is a strings are ordered collections of characters, usually used to represent word and sentence. I use a double quote character to delimit surrounds, separate defines the string value, but I could use the single quote character as well. The choice in which quote character is entirely stylistic. The important thing for the sake of code readability and maintainability is to pick one and use it consistently throughout the program. Another option to delimit a string literal is to use the backticks. However, this choice is not merely stylistic. There is a behavioral difference as well. So exactly for template literals, right? Assuming this program has already defined a variable first name, which the string value Kyle is this, the delimited string then resolves the variable expressions indicating is this. This is called interpolation. So the backtick delimited string can be used without including interpolation expressions, but that defeats the whole purpose of what alternate string literal syntax. Console log, I am confusing you by omitting interpolation. The better approach is to use this or this, right? Again, pick to stick one and reverse only for this string will include interpolation expressions. Other than the strings in JavaScript programs often contains other primitive literal values such as Boolean and numbers. All right, but again, we are describing is here. So for example, a string. For example, a string is a collection, and this is where all of this come from. When you understand the stuff, all right, string are ordered collections of characters. Is a ordered collections of characters, right? And we're gonna see later on in this course how this is defined, which is something that I already know what it is, right? But I could have used a single quote for that. So usually to represent words or phrase, words and sentence, right? That's what it is. So later on we'll see how this is structured. All right. So, but again, we know what this values is. All right. Is this important information? Is important of unit of information, similar as the thread, which is a unit of execution. And this is interesting because who defined that? In the case of threads, that I know that is, I'm stretching the metaphor here, but in the case of the thread, which a lot of people say that this is a unit of execution, who defined that unit of execution? Exactly, the OS. All right, specifically the scheduler, right, which is embedded is embedded in the OS, right, in the kernel. So is whoever designed the kernel, design and define is the set of rules, right? That's quite interesting, because anytime that you look or you want to understand what a unit is, somebody else already defined that for you to actually make our life a little bit simpler when it comes to describe this kind of stuff. So for example, claw define is this. Claw, which is now widely used for this, but it was Claude, not the chatbot. Claude, unit of information. Exactly. Claude Shannon, the father of information theory, bro. So Claude Shannon. Information is the resolution of uncertainty. My mind wanders around and I conceive of different things day and night, like a science fiction writer. I'm thinking what it is were like this. Shannon's most important paper, a mathematical theory of communication, defining a mathematical notion by which information could be quantified and highlighted how information could be delivered successfully over communications channels such as phone lines or wireless connections. Holy mother. I am very seldom interested in applications. I am more interested in the elegance of a problem. It is a good problem, an interesting problem. I visualize a time when we will be to I visualize a time when will we will be to robots what dogs are to humans, and I am rooting for the machines. Holy fuck. Polemic, polemic motherfucker. In 1973, Shannon received a Shannon Award named in his honor and given the Information Theory Society of the Institute of Electrical and Electronics Engineers. It remains the highest possible honor in the community of research dedicated to advancing the field he created. Holy moly, bro. Mm, mm, mm. Holy shit. Damn it. Mm, 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 mm. That's interesting. So Claw. It was Claw, right? So Claw actually was the one who defined this unit of information. Okay, the most important unit of information is the value. The father of the information, the father of the information theory, is Claude Shannon. And I know this might go, so I'm stretching here the metaphor, but the heart of this is what is the truth of this? What is the truth of this? And the truth is that those values are used by the programs to keep the state of that, or to maintain the state. And because we have different type of way of how can we maintain the state of a problem, all right, we have the primitive and the object. So string is one of them. So string is a way of how we can maintain the state like a character, like in this order collections of strings or characters, all right, that it can be, well, in any language possible, right? Again, later on we're gonna see how this is structured. Right now what it is actually using is Unicode right now to describe how we're going to represent is not only known characters in the Western alphabet, all right, but also is on the Middle East or on the hand-based like languages and so on and so forth. And how Unicode is being used and what actually Unicode, what is the structure of the Unicode looks like, and what are the labels or the category that we have on this structure. So we have the basic multiplane, and we also have the astral plane, and this explains a lot of why, for example, we have is this emoji with different visual length, all right? So that was quite interesting, quite compelling. So then you look at how we can use, for example, the string like, all right? So if I go to, series, this is JavaScript. Function like, no. No, but it's not functional JavaScript here. Is exactly this one. Is this one, right? So here we're talking is about the primitive. Like this, exactly. And this is now string values. You say string values in depth. Right, which is good. Then we talk about here is the other than string, JS programs often contains the primitive literal such as booleans and numbers. All right, and we're talking about is literals. Interesting. So this is literals. For example, the following literal, like this, right? It's exactly. So other primitive literals such as boolean and numbers, while represents a loop types a way to repeat operation while it is conditioned, it is true. In this case, the loop will never run and nothing will be printed because we use a false boolean as the loop condition through wouldn't have result in a loop that keeps going forever, so be careful. So the number 3 is, as you know, is an approximation of the mathematical p for a fixed to the first 6 digit rather than embedding such a value. However, we will typically use the predefined math.pi values for that purpose. Another variation of number is the big int, which is something that it doesn't mention here. Primitive, which is used for storing arbitrary large numbers. Numbers are most often used in programs for counting steps, such as loops, iterations, and accessing information in numeric position. We'll cover array objects in a bit, but as an example, if there was an array called names, we could access the element in its second position like this. Exactly. And we use the 1 for the elements on the position and instead 2 because most in programming language JavaScript array index are based on 0 in is the first position. So in addition to strings, numbers, exactly, in addition to string, numbers and booleans, 2 other primitive values in JavaScript programs are null and undefined. While there are differences between them, some historic and some contemporary, for the most part, both values serve the purpose of indicating emptiness or absence of values. Many developers prefer to treat them both considerately in this fashion, which is to say that the values are assumed to be indistinguishable if care is taken. This is often possible, however, it is safe and best to use only undefined as a single empty value. Even though null seems attractive, it is in that it is shorter to type, right? So while value is different to undefined, still goes something. The final primitive value to be aware of it is symbol, which is a special purpose value that behave as a hidden, unguessable value. Symbols are almost exclusively used as a special key on objects. So for example, here, you will encounter direct uses of symbols very often in typical JavaScript programs. They're mostly used in low-level code such as in libraries and frameworks. So let's go into now wrap this up. Okay, we have a string, we have boolean, we have this number and boolean, boolean, boolean. We also have number. Okay. Boolean's number, with this particular example. So here we are using okay, so string boolean numbers, exactly. So here we're using is the literal values. That's interesting that we're using is literal here to refers to something, okay, especially something that is scientific terms or exactly some literals, right, to refers that, which is a scientific terms here. So we are using the literal values. Here we're using the literal values for Boolean and number. For the case of the number, we might prefer to use math.py, since this actually have the value of p, of pi, right? So yeah, we also look at the big int, all right? So this is Boolean in depth and numbers in depth, okay? So Boolean in depth, so number in depth, exactly. So number in depth and Boolean, exactly, and Boolean as well. Nothing too fancy. All right. This was part of my notes. Mm-hmm. Okay. Null. So the other is null and undefined. All right. A way to describe emptiness. It is preferred to use undefined for several reasons. One of them is to avoid the type of the type of null, and it throw you an object here. But type of null, and it return you an object. It's undefined. All right. And then it give you an object string, literal. All right. good. And the other is symbol. The final primitive to be aware of it is symbol. It's a special purpose value that behave as a private value or as a hidden, unguessable value. Okay? And the other is symbol. It's a special purpose value. So a special purpose value. Exactly. A special purpose value that behave. Okay. A special purpose value that behave as an unguessable value. Symbols are almost exclusively used as a special key of an object. Symbols are almost used are almost exclusively used as a special key, as a special key of objects. So for example, in this case, right? So the symbol of meaning of life, and there you go. So for example, if you do this, of course you're not gonna get this 42, right? Because you say, hey, you didn't define that, so you must define this as an object. You do something like this, but it say, hey, this is not a valid expression. In fact, this is a syntax error, all right? It parsed this, so we must do is this. So we must do is something like this. I want to define this, all right? Or you can say something like this as a way to access to this. You can say, hey, this is symbol. With symbols, you don't need to use this new keyword, right? You can create a private or secret, right? Here you can create your own object, all right? And then you can say, hey, I want to add this I want to add now as a property this secret, all right, which will be the value of this. And when I want to retrieve that, it's a undefined because you can have access to that, right? But the idea of this is that this acts as an unguessable symbol. So you might wonder, why do we even care or need to use this? So you will typically encounter this. They're most used in low-level code, such as in library and framework. So they are most likely be used in low-level code, such as libraries or frameworks. But again, this is a special values that allow us to maintain the state of our programs. Hidden, we're going to maintain the state. I'll be right back. All right. Okay. Okay. Mm. You will encounter different uses of symbols very often in typical JavaScript program. They're mostly used in low-level code, such as in library and frameworks. Array and objects. Besides primitive, the other value type in JavaScript is an object value. Mm. As mentioned earlier, arrays are a special type of objects that exactly. The other value type is JavaScript object values. Again, remember, it's just a way. So values are the way how the values are how programs maintain the state, whether it is like in a switch as a boolean, or you want to maintain the state as a character, or you want to maintain the state as a number, or you want to maintain the state as to represent is the emptiness of this, or you want is to now represent is long numbers here, or perhaps now some hidden values right now, right? And then now the object values, right? So besides primitive, the object value, which is another way of how you can represent the data here, the state of your application. So as mentioned earlier, okay, and this is when it comes to data structure and so on and so forth. As mentioned earlier, arrays are a special type of object that comprise of an order and numerically indexed list of data. And I think this might be quite silly, but important as well. So array and objects. So array and objects. Okay. Yeah, why not? Why not? Yep. Why not? I think that'll be good. Yep. Arrays and objects. So, um, so the other type of value, the other type of values, the other type of values is object, right? And there is a special type of objects in array is a special type of object, all right? That comprise uh, that comprise of an order numeric on an order number index or numerical index, an order numerically index list of data, right? But is that, an array is a special type of object that is comprised of an order numerically indexed list of data, right? What is this? It's an order numerically indexed list of data. Data that can be is any of these primitives, as well as it is own arrays or objects, right? So this is when you're starting to see and understand what the value it is. So you can not only is let your programs to maintain the state of the application, whether it's a boolean, so true or false values, or a string, or a number, or a big int, or a symbol, this hidden data, but also as this other type of representations. So for example, like objects or lists of values, or a order, specifically this is ordered numerically indexed list of values, or functions, which is object types, a set of instructions here. So, and when you're starting to see this, you also look at other type of data structures, right? Not only is the basic the primitive, but also how you can compose other type of data to represent things on your computer. So or in this case, for example, if you want to represent here now is the navigation like this, well, a way you can represent is through a linked list or to a double linked list. If you want to, for example, represent is how do you receive all of these incoming requests, so you can treat that as a queue, all right? Or, so for example, how you're going to process something. Let's say you have now a pile here, all right? A pile of all of these documents. So how are you going to process all of them? Well, a stack is a good way to do that. Another representation is a tree, the tree likes. All right. When you want to now have access to the information as fast as possible, unlike other type of data, unlike other type of organization, is quite. For example, you want to find if there is a collection. If you want to find the data in a list, in a order numerically indexed collection, you have to go through all of this until you find. However, there are now alternatives to do that, right? So you have is the binary search, right? When you split, where is this? As long as it is a numeric order, right? So you want to split where is this? Say, hey, this is on the left, this is on the right. If it's whatever it is, let's say this is on the right. All right, so good. Now let me actually look at this portion. Hey, we can look in the forward, and so on and so forth. You know, until we find that element. Um, but again, some techniques. There are techniques to actually achieve something, and the reason to understand these techniques is because the value that is because it's not only the value, but also is how are you to think about a problem. Are you able to systematically look at that? All right. Can you describe that problem in a very systematic way possible? This is all about this, man. So, okay. So as I mentioned earlier, are a special type of objects. So you have this order numerically indexed collections or numerically indexed lists or collections of data. In this case, it's made of a string, all right? So for example, like this, JavaScript arrays can hold any value type, either primitive or objects, as well as toward in the end of the chapter 3, even functions and values that can be held in an array of objects, like so. So this particular example here is just as a way to copy here. Let me put this like so here. There you got it. Go back to Arial. And JavaScript can hold any value types. Exactly. In JavaScript, arrays can hold any value type. Okay? So either primitive or object, all right, including other arrays, right? As we'll see toward the end of the chapter 3, even functions are valid that can be held in an array of objects. Exactly. Even functions are valid that can be held in arrays or objects, as well as functions that can be held, okay, that can be held in arrays or objects. So functions like arrays are a special kind of subtype of objects, and we'll cover this in more detail in a bit, right? So functions are a special type of objects. There's a lot of people that actually repeat that, which is that hey, objects are this it's in a special type of objects, right? And this is why JavaScript is known as the functions are first-class citizens, right? Because they are now objects and functions, right? And objects are more general. Objects are more general. And objects are more general. And this is also true when, for example, you compare your nodes with people like Axel Ross Meyer, where he describes what is the nature of the objects in the array. So an array behave like what is the role? What is the role of an array? whether it's a tuple or a collection, right? As a tuple, exactly. Whether it's as a tuple or a collection or as a list. So a tuple is a fixed length where each one of those elements, the value can vary. But a collection is uh, is an unknown length of elements, right? It is a resizable, is a non-fixed. Uh, yeah, it's a non-fixable length of collections. Is a non-fixable list, uh, or is a dynamic length list that each one of our elements must have the same value, the same type, as well as object here, right? So whether it's a tuple or list, right? So the role can be a tuple or a list, right? And here you have now the role can be a um, a dictionary, or a record, all right? So the dictionary is that it is a fixed length. It is a fixed length of property, all right? Yeah, this is interesting. This is interesting because I don't know. Hmm. No, it's here. I think it's this, which is double. I think is primitive literal. The types, any, no, never. Type inference. A tuple. Is here? I think it is. Exactly. There you got it. It's a fixed layout object and dictionary object. This is the definition. The typing objects. Exactly. So when you describe here this fixed layout object, which is a record, all right? And okay, you have now dictionary. If you have now fixed layout objects. So this fixed layout objects or record, it has a finite number of property that are known at development, where each property can have different type, okay, different value. And a dictionary object is an arbitrary number of properties whose names are not known at development time, and all property have the same type. Mhm. And all property have the same type. We are ignoring dictionary object in this chapter. They are covered in index signature objects and as dictionary. And aside, maps are usually a better choice for dictionary anyways. Index as signature objects. So what is this? Okay. Okay, add please unblock. Gladly, I want. Mm-hmm. The basic of TypeScript. Mm-hmm. Whose keys are not known at development time and all their values have the same type. Mm-hmm. Members of object literal types like this. Property signature, method signature, index signature, call signature, and construct signature. Okay, but this is something that we're gonna see that as we move on into the course. All right. So, for example, something like this. So, a good example of this is like this. All right. So objects are more general, an unordered key collection of any various values. In other words, you access the element by string locations, name aka or property, rather than in its numeric position. But again, this is an unordered key collection. An unordered key collection. And construct signature, for example, like this. Here, .me represents an object and first represents the name of its location in this value, which is represents the location of this. So if you're going to locate this, the only way to do that is by knowing the property at hand. Value type determination, and then you have is this, okay? The value type determination. So value type determination. Using is a type of, right? Using is a type of. Mm-hmm. So using as a type of, this is how you can determine. So using the type of, you can determine the value in a string like. Okay, using the type of, you can determine the value of a string like. Um, in a string like, using the type of, you can determine the value uh, the value uh, in a string, right? So for example, we got all of this. We got all of this. Okay. All right. And we're back. Good. Exactly. Type of null unfortunately returns objects instead of expecting null. Also, type of returns a specific function for function, but not the expected array for array. Since arrays are special objects, all right? Since array are on special objects and they don't return that. So converting from one value type to another, such as from string to number, is referred to in JavaScript as coercion. We'll cover this in more detail later in this chapter. Primitive values and object values behave differently when they are assigned or passed around. There you go. This is not the behavior of this. Primitive values and object values behave. Okay, converting from one value type to another, such as strings to number, is referred as JavaScript coercion. So here we're talking about is the value determination and transformation. And value transformation. Mm-hmm. And value transformation. So primitive values and object values behave differently when they are assigned or passed around. We'll cover this detail in Appendix A, value versus reference. All right. Exactly. This is value determine and value type determination and converting from one value type to another, such as from string to number. And it refers to JavaScript as coercion, and we'll cover this in more detail later in this chapter. Primitive values and obvious values behave differently when they are assigned or passed around. And we'll cover this detail in Appendix A, values versus reference. So, yeah. So coercion, which is the thing that I already looked. Coercion is how the language convert one value to another by following a specific algorithm known as abstract operations. All right, so you have now specific abstract operations for that, and those specific abstract operations are like, if you take a look at the ECMA, all right, this is in 2018, but it will work for our purpose. Let me do this. To actually fetch me is the latest state of the language, 2025. So for example, things like the where in the F abstract operations like that, right? Type conversion to primitive to numbers, to use string to big int, right? Testing and comparison is another one, right? All of these are, and here's describing is the behavior of all of this abstract operation, all of these methods. So the type conversion, testing and comparison objects, all right? So for example, is array, okay? So the abstract operation is array takes arguments of the language and returns an either a normal completion containing a boolean or throw a completion. But for example, all right, if argument is not an object, it's going to return false. If argument is an array exotic, return true, right? And then you can dive deep of what actually is this array exotic, what defines an array exotic, the define own property, internal method of an array exotic object like that, all right? And then return a normal completion of boolean here. And here is describing is this is the P of the property is length. Then what it's gonna do is to return array set length that. If P is an array index, then it's going to assess through that in a way to determine that, you know, but as you can see here, I'm not going to dedicate too much time to this, but you can see is the algorithm that is following here, the define own property, right? Array.create, array special, string exotic objects, and so on and so forth. So even though the language in itself is telling you that, so for example, if you somehow, since this is not our, as you can see, our is array and the argument is array is not defined, which is interesting. So this hidden or abstract operations which are not defined, which are not defined in the language, but the language actually used to calculate that, right? So for example, is less than, or is loosely equal, right? Or is strictly equal. For example, here in the is array is this. The abstract operation is array takes arguments this. The question is that how can you have access to the array? You know? Is there a way of how you can detect this? It's callable. You know, it's a constructor, it's extendable, it's regex expression. But again, it's all of this internal operation that's happened when it performs some operations. So for example, here is when it's saying that is less than, is loosely equal. For example, is this. It provides the semantics for the operator of this. That's quite interesting. In the case of this array, how the F do you do this? Require object coercible results. So is array in JavaScript? Exactly, but it belongs to the array in itself. Oh, it belongs to the array instance here. The standalone built-in objects. Okay, so for example, you say, hey array, is this an array? You know, whether is you pass this, all right? Is this an array? And it's gonna check that as long as it's this. Even if this is now a proxy here, new proxy of an array, cannot create proxy with a non-object as target, as handler or handler. Oh, it's because in fact I don't know how to create this. Cannot create proxy with a non-object as target or handler. It's because, well, again, this goes beyond the scope of this, but the thing here is that here we hold is this abstract operation. Is this operation that is done by the language. All right, operations on objects. Get method set has some property, invoke, enumerable, blah 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 blah. And a lot of people say that this is about it is about practice. Practice with intention is about understanding. Get iterator direct objects. Get iterator from methods. Get iterator from here. Direct syntax here. Scope analysis and labels and all that kind of stuff. So go back to what is relevant to ourselves, which is taking notes out of this. Okay. So coercion is how the language converts one language to another by following a specific algorithm known as abstract operations. Okay. Similar to this, primitive values and objects are passed, behave different when they are assigned or passed around. Behave differently when they're assigned or passed around. Behave differently when they are assign or pass along. Or pass along. We'll cover this detail in Appendix A, value versus reference. Okay. So we'll cover this detail. Yeah, we'll cover this detail in Appendix A. In Appendix A, value versus reference. Values versus reference. Declaring and using variables. To be explicit about something that may not be seen, may not be, okay. Declaring and using variables. This is another topic. Okay. Declaring and using values. And using variables. Okay. Give me a pause here. I'll be right back. And we're back. Now, we were looking at the declaring and using variables. All right. So yeah, let's get going. So to be explicit about something that may not have been obvious in the previous section, in JavaScript programs, values can either appear as literal values, as many of the preceding example illustrated, or they can be held in variables. Okay, so this is there is this concept in this language when values can be held, okay, or can be either appear as literal and as they can be either appear as literal or they can be held in variables. Think of variable as just a container for values. And I want to take note of this because despite that it might sound quite silly, similar for the values and what the value it is in any programming language, particularly here in JavaScript, is this most important unit of information. Exactly, unit of information that allow programs to store or that that allow programs to store the state of the application. Okay, so this way of maintaining is the state of the apps, right? Using now values. So values are data, and data is the way of how values are how the programs is how the programs holds its internal state, is how the programs keeps its internal state. There's a particular word, but anyways, so this is now how so values are how programs manage its states, how programs so how programs it's like so values are how programs persist. There's a particular word that I don't convey, which is this is how it persists or maintains This exactly maintains of this, maintains, right? And maintain is that, so yes, so the values are how programs maintains the state, all right, and it can be, and in JavaScript it splits in primitive and in objects, and in any other programming language you have a particular way of how they can split that unit of information, that way of how programs maintain the state of the applications. So how they maintain the state of booleans, whether it's true or false, or a ordered collections in an index, or this ordered collections of characters in an index, in because yep, it's an order of collections of characters to represent now words and sentence, how they can be used to maintain the state of this, all right, whether it is numbers, or if you want to how numbers are represented using is the IEEE 7054 spec that describes how these numbers actually works, and the in the stream as well. So how now not only that the programs maintains the state of the app, all right, but also how that actually is being represented in the case of Unicode, and why do we have now, for example, basic multiplane, natural plane, or for example is how now the programs manage the state of the symbols, all right, and what are the main use case of this. It's like, hey, your building is now this internal tools for low-level code or libraries or frameworks as a way to now have some unguessable private data that you want to store, you want to hold inside of an object. This is why you can, the tool that allows to do that. All right. So we have is the strings, numbers, a big int. So because the int actually have a limitation, and any programming language that implement the number using this rule or using this spec, all right, pretty much like when you go out and you want to build, let's say, a Millennium Falcon, right? So if one of those pieces are not, or if there is, if you don't follow the particular instructions of that, or even if the instruction in itself tells you that this is the way how to build a Falcon, all right, or a regulable table, which is something cool. You can also buy that. Regulable tables or portable wardrobes. So because you already have all of these instructions, if those instructions actually now comes with some flaw in itself, which is exactly what happened to the IEEE 754, and is those flaw is because it's a more mathematical aspect of this, but it's the way of how you can accurately represent these numbers, right? So accurately, by accurate we mean is that with how much precision can we describe as a number, all right? So for integers numbers, so far so good, but what about when things are not whole numbers, right? When you have now fractions, when you want to identify how, for example, you can now accurately is represent the number of pi, all right? So on and so forth. So this is exactly how now this number language, or the number of any programming language that use this spec to um, implement the numeric representations of in a particular language actually follow and fall into this particular issue, right? It is important just to understand that, to recognize is the limit of that, and why, for example, there is an alternative in JavaScript to fix stuff or to describe bigger numbers than that, right? And perform some operations on that. So begin is another one. I don't actually mention begin, but I supposed to mention here the begin. Okay. Right. And then how you can describe or represent is emptiness values, whether it's undefined or null, and why it is preferred to use undefined, especially when you want to check the value of this, you actually get that particular string, right? Unlike, for example, with null, which the value gives you is an object, and this is for historical reasons that I don't want to dive deep into this, but it is preferred to stick is with the undefined for that, right? And then how you can check the value of this, and what I'm looking right now is at the exactly how you can is detect the value of one of these values, using the type of, as well as how also you can use it, for example, array and objects, right? And what is objects, and what is an array, and how now you can use array, which is a special type of objects, to describe this order index order index order numerically indexed collections of values, and the uh, and how you can also use that not only for any value, but also is with array in itself, or functions, or objects, and why object it is, and what is the role of objects. All right, so you have now dictionaries and records, and the dictionary is this key value pair objects, all right, which you don't have all the property of runtime, all right, or you don't have all the property before runtime, and all of those values must be is the same, right? Whereas the record, right? So you already know in advance the shape or the keys of this object, all right? And the value can be any type, right? So the idea of describing is when it comes to now look at the way of how you can convert values, using is this abstract syntax operation, which is a fancy way to say this is an algorithm that the language define, that is for internal use. You don't have you will not, so the language doesn't expose that to you, but this is something that's happening behind the scenes. So for example is the case of the type coercions, and the coercion in itself, the double equal, the triple equal, and what are the algorithms, something that we're gonna see that later, right? But here, okay, in declaring, and now there is also a way, this is also a way of how now the values are passing by reference, and because they behave the same. So when you pass primitive objects, they behave differently, depend of how they are assigned or pass along. And I think this is two important concepts here: when they are assigned or pass along. All right, so we'll cover this in detail in Appendix A. So value versus reference, and what we are reading is now this, right? These things. So declaring and using variables. Okay. In JavaScript programs, okay. So in JavaScript programs, values can either appear as literal or they can be held in value. Okay. Again, if this wasn't obvious, okay. If this wasn't yes, if this wasn't obvious, okay. So if this wasn't obvious in previously in JavaScript programs, values can be either literals, all right, I will prefer to go and use this, literals, right, or can be held inside of variables, all right, it can be held in variables, can be held in variables. Okay, can be held in variables. Think of variable as just a container for values. Okay, so think of values as a container of think of variables. Think of variables as a container of values. All right. In variables, which is this container of values, all right, have to be declared, created, to be used. In variables, depend on this, depending which mode you are, so variables can be declared, created to be used. Variables have to be declared. Variables have to be declared or created to be used. There are various syntax forms that declare variables. Oops. Oh. Is this one? There are various syntax forms that declare variables, aka identifiers, and each form has different implied behaviors. Okay. So variables have to be declared, created, or to be used, and variables are a container of values. And values, and this entirely description of or this backward storytelling is something that is important for you to make sense of why you're doing the thing that you do. Period. Just like that. So variables have to be declared, created, to be used, and there are various syntax forms that declare variables, aka identifiers, and each form has different implied behaviors. All right. So there are various syntax forms that declare variables, aka identifiers, and each form has different implied behaviors. So for example, okay, each one of those forms, okay. So variables have to be declared or created to be used, and there are various syntax, and there are various syntax to declare to declare them, okay, or to declare variables or identifiers, right? Identifiers. To declare variables or identifier. Each form has different implied behaviors. And each form, the syntax, has an implied behavior. Has different implied behaviors. Or each form has a different implied behaviors. This is when it comes to the let, the var, the cons, right? So for example, consider the var statement. So var my age Kyle, nh. The var keyword declare a variable to be used in that part of the program and optionally allows an initial assignment of the value. Another similar keyword is let, for example, like this, right? So let my name is equal to Kyle, and let age as it is. So the let keyword has some difference of var, with most obvious being that let, exactly, the let keyword has some difference to var, with the most obvious being that let allow a more limited access to the variable than var. This is called block scoping, which is something that we're gonna see that later in the scope enclosures. And it is called block scoping, as opposed to regular or function scoping, right? So this is it. It all starts with this. So var and let has different var and let has different behaviors for declaring variables. The first is focus on functions, variables, or identifier variables, declarations, okay? The first is focus on variables, functions, declaration, and the latter express a more constrained use of a variable, block scope, known as block scope. All right, so mind blowing. That's interesting. As opposed to regular or function scoping, right? So the former is so the former is functional scoping, okay? Functional scoping, as opposed to the latter, exactly, as opposed to the latter that express a more constrained, or which express a more constrained use of a variable, known as block scoping. All right, known as block scoping. So for example, like this. All right, so for example, like this. Pretty silly, all right, of the name var my name, which is now overridden here. You can override the value of this container if they call the same. But again, this is going to be a scope at a global level or at a function level, right? So you take access to my name, you're gonna get access to the name Kyle. If you want to access to the age, you will not, because you are outside of that block, right? And in the attempt to access age outside of the if statement result in an error. Question is that when this error should happen. Hmm? So, exactly, when this error should happen, if by the time that it analyzes it, or by the time that it parses this, and then it execute that, it will stop here, indicating that, hey, the error that is thrown here, it was at runtime, it was by the engine. Exactly, it was by the engine. And it is interesting, because this is a secret. Exactly, go into this, and it doesn't perform any other code of that. So this reference error, for example, is something that is now it was performed during the execution of the code, right? That's the idea here. So why this is important? Because, well, when you are evaluating is this and this another one, what is telling you, hey, this reference error, it means that is something that happened at runtime, right? So, blah here. So, reference errors are errors, unlike syntax errors, are errors that happen at runtime, as opposed to the latter, where it happened at parse time. Mm-hmm. Exactly. That's what you have now, the concept of temporal dead zone and so on and so forth. And I'll be right back.